Hello everyone. Today I want to show you about the vectorized code. So, what is vectorized code? So, the meaning of the vectorization in Python is improving the performance of operation on data, particularly with load dataset by executing a single operation on multiple data points simultaneously. So, basically, in my understanding, instead of using looping like this, we can just using or doing the one operation that this looping operation do, like this here. So this is the function in here. This is the factorized version for these lines of code. But before that, I want to explain the task that we want to do in here. So here I have a radar image. So actually this radar image, when it's designed to only have these colors, but when we convert it to, for example, PNG or JPEG, there will be another color beside of this. So okay, let me show you. Okay, so in here, the code in here, it's to detect all the color RGB combination in the image in here. So as you can see here, first we open the image radar file. Radar file is the radar PNG, and then we open it as numpy array, and in here we reshape it. We flatten the image except the color channel, and then here we detect all the unique combination in here in axis 0, and after that we print all of that. Okay, let's test this. And as you can see here, we have many combination, and that's why in this test, for this vectorized for this vector experiment, I want just this color axis in the image. So actually this is just the excuse, or this is just for the sake of this experiment. Okay, let's comment out this code. And okay, now I want to explain to you about the code. First, I want to explain about the default code we have here. So this is non-vector code. Here we make a numpy array from the list in here is generated by the for looping in here. So we doing the function find clustered colors in here times the total pixels we have in here. So we doing this, and we doing this find clustered color per pixel of the image that we want to check in here, or radar.png in here. Actually, the shape of this image is, this is the shape of the image, so it's about 400 times 400. So it's about, so the total looping or the total operation that we will do, it's about 1600. But what the find closest color factorized, or the factorized version of this function? So basically what we do is like this. Actually this is same like np reshape, but in here we using the np new axis. So np new axis is like, if you ever using a python, it's like unsqueeze method. Just google it so you can understand it. And then after that, here we using the Euclidean distance between the original pixel and then with the color list in here the allowed colors in here. So here this is basically just the Euclidean distance formula, the formula that where is a plus b and then you power of it by 2, and then after that uh, you find the square of it, something like that. And then after that, here we search the index of the lowest value using numpy argmin. So using this code, the only color code that we have is just limited to the combination color in here. Yeah, something like that. Okay, now that is how the factorized code version and the default code version works. Now, how we determine which code is more efficient? Actually, if we can maybe calculate the flops, maybe we can use that. Actually, I think it's more objectively to or more good to determine which is which code or which line code is more efficient, but unfortunately I don't know how to count flops, so instead of using flops I will using the time computation that the code in here need. So first, let's test the time that we consume if using the default code. So this is the non-factor code here. So if you're using Linux, you can determine the time of the code using time command like this. Okay. And the time is 4 seconds, 4.4 seconds. Okay, now how about we using the vectorized version of the code. It's only 1.7 seconds, and as you can see here, it's quite significant, because imagine if we have multiple images like this in here, the difference will be more bigger, right? So that's why when you doing a code, actually you must avoid using a looping like this. So instead of this, using the factorized version like this. I think that's all. Thank you. Bye.